For centuries, humanity believed the universe could be understood. We mapped the stars, measured motion, built equations powerful enough to predict eclipses, explain gravity, and describe the expansion of space itself. Little by little, we began assembling a story of existence. A universe governed by rules. Predictable. Logical. Ancient, yet understandable. We imagined reality as something waiting patiently to be decoded. Like a puzzle with enough pieces, eventually revealing its full picture. And for a time, that confidence seemed justified. Galaxies formed according to known principles. Stars were born, evolved, and died. Gravity sculpted matter across billions of years. Everything appeared to follow a timeline. A slow cosmic unfolding. Simple beginnings leading to increasing complexity. At least, that was the expectation. Then humanity built a machine capable of seeing farther than ever before. The James Webb Space Telescope. A telescope unlike anything humanity had previously launched. Not designed simply to observe the sky, but to peer backward through time itself. Because in astronomy, distance is memory. The farther we look into space, the older the light becomes. Some of the signals captured by Webb began their journey billions of years ago, long before Earth formed, before oceans existed, before life emerged. Each photon arrives carrying evidence from a forgotten age. And when Webb opened its eyes to the deep universe, something unexpected happened. The story stopped making sense. What it revealed was not chaos becoming order. Not simplicity gradually growing into complexity. Instead, Webb discovered something stranger. A universe that seemed to mature far too quickly. Galaxies appearing older than they should. Structures larger than expected. Patterns emerging too soon. Reality moving faster than theory allowed. Suddenly, astronomers found themselves confronting a deeply uncomfortable possibility. What if the universe we thought we understood is incomplete? One of Webb's most extraordinary observations came while studying unimaginably distant regions of space near ancient galaxy clusters. Scientists expected faint, primitive galaxies. Tiny irregular formations barely beginning to organize. According to standard cosmological models, the infant universe should have looked messy. Unfinished. A rough draft of reality. Galaxies in those early eras should have been small collections of gas and newborn stars. Disordered. Chaotic. Still struggling to take shape. Instead, Webb found brightness. Mass, structure. Some galaxies appeared unexpectedly mature. Dense glowing centers. Disk-like organization. Evidence suggesting astonishing levels of development. It was as if astronomers opened a history book expecting primitive settlements, only to find towering civilizations already standing. Naturally, skepticism followed. Science survives by doubting itself. Were the measurements wrong? Could the galaxies simply be closer than expected? Distance in astronomy depends heavily on redshift, the stretching of light caused by cosmic expansion. If those calculations were slightly inaccurate, perhaps the mystery would disappear. But observation after observation returned the same unsettling message. The galaxies were real. Ancient. And remarkably developed. The deeper Webb looked, the stranger reality became. Across vast distances, patterns began emerging. Immense clusters of galaxies appearing connected through sweeping structures stretching across space. Matter gathering into enormous formations with surprising coherence. At first glance, it almost feels architectural. As though hidden order lies beneath cosmic randomness. Of course, astronomers remain cautious. Gravity alone can organize matter. Over billions of years, invisible forces naturally sculpt galaxies, stars, and clusters into larger systems. No credible scientist believes the universe is intentionally designed because of a few unusual observations. But timing matters. And scale matters. Because some of these structures appear startlingly early. Too much organization. Too soon. Not impossible. Just unexpected. And unexpected discoveries are where science becomes most interesting. Then came another mystery. Planets. Massive worlds forming far faster than expected. Imagine a giant planet several times larger than Jupiter orbiting a young star barely beginning its life. According to traditional planetary formation models, such worlds should require enormous amounts of time. Materials slowly gathering. Dust becoming rock. Rock becoming worlds. Gravity patiently assembling planets over millions of years. Yet Webb observed planetary systems pushing those assumptions to their limit. Objects appearing enormous despite cosmic youth. Some researchers suggest these planets migrated after formation. Perhaps gravitational chaos pushed them outward. Perhaps they formed under rare circumstances. Possible? Yes. Comfortable for existing models? Not entirely. Little by little, Webb continued revealing the same unsettling pattern. Reality behaving strangely. Not breaking the laws of physics, but stretching expectations. Pressing against the edges of certainty. And perhaps the strangest part is this: none of these discoveries overthrow science. They strengthen it. Because science is not belief. Science changes. It adapts. It evolves whenever reality refuses to cooperate. The James Webb Space Telescope was expected to confirm our understanding of cosmic history. Instead, it exposed how unfinished that understanding truly is. For generations, humanity imagined the early universe as quiet. Slow. A gradual climb from darkness into complexity. But Webb hints at something else. A cosmos moving with startling urgency. Galaxies rising quickly. Structure appearing early. Complexity arriving almost impatiently. And now, humanity stands in a strange new position. Not at the end of understanding, but at the edge of deeper questions. Because the farther we look into ancient light, the less certain the universe becomes. And somewhere inside that uncertainty, a larger truth may still be waiting. But galaxies that formed too quickly were only the beginning. Because once the James Webb Space Telescope began exposing cracks in expectation, the mysteries multiplied. And some of them feel almost unsettling. For decades, astronomers believed the universe evolved through understandable stages. Hydrogen collapsed into stars. Stars forged heavier elements. Galaxies slowly matured. Everything followed a timeline. Messy beginnings leading toward order. But Webb's discoveries whisper something more complicated. A cosmos that may have become structured far earlier than expected. A universe strangely impatient. Across unimaginable distances, astronomers began noticing enormous arrangements of matter stretching across the darkness. Vast intergalactic highways known as the cosmic web. Invisible scaffolding connecting galaxies over hundreds of millions of light years. According to theory, these structures exist because gravity slowly gathered matter together over cosmic time. Dark matter, the mysterious invisible substance believed to make up most of the universe's mass, acted like a framework. A hidden architecture shaping reality. And in many ways, observations confirmed expectations. But in certain regions, something felt unusual. Galaxy concentrations rising and falling in curious patterns. Large-scale arrangements appearing surprisingly coherent. Almost rhythmic. Almost organized. Not impossible. Not proof of anything extraordinary. But enough to make scientists pause. Because sometimes, discovery begins with discomfort. The realization that reality behaves differently than expected. Then there was another strange phenomenon. Light itself bending into impossible shapes. Long ago, Albert Einstein predicted that gravity could distort space, curving light as it passed massive objects. A galaxy positioned precisely in front of another distant object can act like a cosmic lens, bending ancient light into spectacular circles and arcs. These phenomena, known as gravitational lenses, are understood in theory. Expected. Predictable. Yet Webb captured examples of breathtaking precision. Near-perfect circles formed across billions of light years. Alignments so exact they appear almost unreal. Of course, the universe is vast. Rare things become inevitable given enough scale. Astronomers understand this. Coincidences happen. But Webb keeps delivering moments that force scientists to look twice. Not because reality is broken, but because reality seems more elegant than expected. And then came something even stranger. Signals. Brief bursts of brightness. Repeating fluctuations. Patterns appearing, vanishing, then returning. To be clear, no serious scientist claims Webb detected alien messages. The universe constantly produces unusual events. Exploding stars. Magnetic storms. Rotating stellar remnants. Violent eruptions from supermassive black holes. Most strange observations eventually find explanations. But occasionally, something refuses to fit comfortably. A signal repeating at regular intervals. Steady. Rhythmic. Persistent enough to deserve attention. Instrument error was investigated. Alternative explanations tested. And while no conclusion exists, the mystery remains under study. Perhaps it will prove entirely natural. History suggests many mysteries do. But science advances precisely because curiosity survives uncertainty. Meanwhile, another puzzle emerged from ancient starlight. Chemistry. When astronomers analyze distant galaxies, they examine light like detectives reading fingerprints. Every wavelength carries hidden information. Tiny clues revealing what elements exist across space. Hydrogen. Helium. Carbon. Oxygen. Iron.